Hello everyone, in this session we'll discuss shift microoperation. Shift microoperations are used for serial transfer of data into the registers. Now they are also used in conjunction with arithmetic and logical operations which we discussed earlier, like combining arithmetic operation with logical operations and performing some shift operations will get some desired outputs. Okay, so what happens is the content of register can be shifted to the left or right depending on our choice. Okay, now the first flip-flop will receive the serial input. What we provide, the first flip-flop either onto the MSB side or onto the LSB side, whatever we provide. The information transferred through the serial input determines the type of the shift. Okay, so question arises, what are the types of shift available with us? Let's see one by one. Types of shift. The first is logical shift. Logical shift will transfer 0 through the serial input. Okay, how? Let us see the first type of logical shift, that is logical shift left. Suppose consider register R1 contains 1101. So logical shift left will perform the shifting of bits to the left side by position 1. Okay, so we are having, let us say this bit 1 is shifted to the left side, bit 0 shifted to the left side, bit 1 shifted to the left side. Now the question arises for these two positions. What about this MSB1 and what about this LSB position? This MSB position would be discarded. So this one would be discarded, and through, as per the definition of logical shift, 0 would be transferred through serial input over here. So over here it would be 0. So this is logical shift left. And similarly we are having logical shift right. Okay, so a bit by bit would be shifting to the right position by 1. Okay, so this 1 would be shifted to the right side in this way. But now question arises for this LSB1, it would be discarded. And what about this MSB in the output? As per the definition, serial input will give 0 over here. So this is logical shift right. A slight variation to this logical shift right, instead of providing 0 to it as a serial input, we are having second type of shift, that is a circular shift, which performs the rotation operation. So as it is rotating the information, no new information is added and no information loss will occur. So the output of the shift register is connected to the serial input. So let's see the example. Circular shift left. Register R1 contains 1101. We want to perform circular shift left. So the bits would be shifted to the left side. So 1, 0, 1. Now circular. So this MSB bit would be circulated to the LSB over here. So this is circular shift left. Similarly, we are having circular shift right. So the bits would be shifted to the right side. Okay. But circulate means the LSB over here would be circulated to the MSB in the output. So this is circular shift. And the third type of shift what we are having is arithmetic shift. Now arithmetic shift is performed onto the signed binary numbers, means positive or negative information. Again, it can be shifted to the left or right, whatever we choose. Okay, but if we perform shift left, arithmetic shift left operation, then it is the multiplication of signed number by 2. And if we perform it to the right, that means arithmetic shift right, then it will divide the number by 2. Okay, how? Let's see. Arithmetic shift left. So it is shift left operation only. Logical shift left only. So bits would be transferred to the left side. But as you can see, we are having it can be performed on signed binary numbers. Though MSB signifies the sign. So 1 means negative number. Okay. So it is normal, our logical shift operation. Logical shift left, as we had seen earlier. So the question arises, what about this LSB? So this LSB would be 0. So no issue with this. But the actual question arises is in arithmetic shift right. Okay, shift right sign bit. So let us perform shift right first. So shift right, 0 shifted to right side, 1 shifted to right side, this one shifted to the right side. But the question arises, what about MSB over here? As it is arithmetic shift right, the content of MSB would be copied directly to the MSB itself. There won't be change in that because it is shift right operation. So there is what is the difference between shift right and shift left. Shift left is our normal logical shift left, but in arithmetic shift right we need to check for the MSB. MSB should not change because it is a sign. So sign should not change. So these are the types of shift. Now let's see the hardware implementation of this particular shifter circuit. We need 4 mux. As you can see, 4 mux we are requiring. They are of size 2 cross 1. So 2 cross 1 means we require 1 select line only. So select lines will decide which operation we are going to perform. If it is 0, then we are going to perform shift right. If it is 1, we are going to perform shift left. Okay, so before moving further, let us see the output. We are saying H0, H1, H2, H3. But before giving this input, let us see the truth table for this function table. So if I say input select line is 0, that means we are going to perform shift right. So the bits are transferred onto the shift right. So serial input would be IR, A0 shifted, A1 shifted to the right side, A2 shifted to the right side. But if I say select line is 1, then we are going to perform shift left operation. So in that case, A0 is discarded, A1, A2, A3, and IL, which is our serial input from the left side. If we provide IR to be 0, then it is our normal logical shift right. And if we provide IL to be 0, then it is our normal logical shift left. But if you want to make it circular shift, then over here at the input of this shift input, we need to provide the output of the shift register. Okay, so let's see one by one. So we are connecting, as you can see, IR is connected to the 0th line because we want to perform shift right. So IR is connected at the 0th line. So A0 to be connected to the second mux 0 line, A1 to be connected to 2 places, as you can see from the table. For H2 we require A1 over here into the 0th line, and A1 is also connected to the H0, so over here into the first line. So you can see this, A1 is connected to the first line of the first mux and it is connected to the 0th line of the third mux. So we are having A1 over here at the 0th line, and we require A2 at H3 line. So we require 0th line to be A2, and A2 is also there at H1. So at the first input we are having A2 over here. So A2 is connected in this way. And the last A3, which is there only for H2 line output. So when select line is 1, A3 is connected to H2. So like this. And the last one left out is IL. So IL is connected to the first line of 4th mux. So this is what is the circuit implementation. Now let's see an example. We want to perform the logical shift right onto 1 1 0 1. Logical shift right. So 0, but natural select line we need to select to be 0 for shift right operation, which we had done. Okay, now the shift right operation, so over here the first bit would be 0, as from this you can see from the function table. So now H1 would be A0, so A0 is 1, it goes to H1. Now H2 is A1, so A1 would be at this position, and H3 is A2, so over here H3 is A2, so this 0 would be transferred over here. And A3 is to be discarded, so 1 is discarded, A3 is discarded. So basically we had performed logical shift right 1 1 0 1. So 1 1 0, and the most significant bit would be 0. So this is how the circuit works.